With climate change now very urgent, one of Ireland's biggest challenges is to dramatically reduce energy use and CO2 emissions from all our homes. Right now, we're a long way from that possibility, as over 1 million houses in Ireland have building energy ratings that fall well below a C, while 98% of home heating is currently sourced from fossil fuel.
That means millions of us each year spend a fortune on trying to heat our cold, damp, and often unhealthy homes.
Typically, householders have tried to address this problem through a kind of pick-and-mix approach to energy upgrades, such as insulating only the attic, or just fitting solar panels. This is what's known as a shallow retrofit.
Wouldn't it be great if we could all live in warm, comfortable, A-rated homes? Deep retrofits can achieve the comfort and performance of a brand new house.
But how viable is it to get a typical old house to this new standard? Carrying out a deep retrofit means looking at the energy performance of the entire house. This time on EcoEye, we meet two families who have taken on the challenge of bringing their homes all the way up to an A energy rating. We explore what supports are in place to help them to do this, and we ask the question if it's really worth the time, money and effort. One quarter of Ireland's energy-related CO2 emissions are created by our inefficient housing stock. To date, 400,000 dwellings have had some level of energy upgrade, supported by the Sustainable Energy Authority of Ireland. But there are still at least 1 million homes that need serious energy upgrades involving significant work. The government's latest attempt to address this is the SEAI's Deep Retrofit pilot programme.
Tell me about the deep energy retrofit. It's called deep for a reason.
Yes, it's a full package, a full suite of measures that you're maximising the energy efficiency by insulating the house to a high degree, then you're heating with renewable systems, and then you're ensuring good indoor air quality mechanical ventilation. And that's essentially what they've done here.
This social housing development in Milltown was built in the 1980s and had energy ratings as low as F and G. The aim of the Deep Retrofit programme is to transform houses like this all the way up to a BER of A3, which would reduce energy demand by a whopping 80% and CO2 emissions by 90%.
They must be incredibly unhealthy.
Absolutely. We're doing some work with the HSE on our Warmth Wellbeing programme. It's a pilot as well to see the difference that improving the energy efficiency makes to people with chronic respiratory diseases such as COPD. So it's an early start to that, but there is definite evidence coming through that it's having a difference in terms of visits to the doctor.
Well, it's great to see social housing like this available now at A rating. That's fantastic. But what about private housing?
Well, ultimately the programme is going to be aimed at the private market to bring all those private homes up to an A rating. And while the cost it can be high for this type of work, we do have a 50% grant towards the cost of that work.
50%?
50%.
That's really, really generous, isn't it?
Absolutely. Well, the cost is high, so the incentive we have there, the grant is there to reflect that.
In addition to the grant, there are also significant other savings to be made with an A3 rated house.
Well, an average house across the country would spend maybe of the order of $2,500 a year for heating. On bringing up to an A rating, an A3, you're looking at probably of the order of €500 a year or less.
So you're saving €2,000
up
every
to
year?
€2,000, yeah, it could be up that.
And it probably adds good value to the house also if you go and resell the house, does it?
Absolutely. Well, the ESRI have done a study in 2015 saying that an A-rated house would attract a 9% higher value than compared to a D-rated house.
It might be generous, but this grant is the type of support that's badly needed for householders so that they can pay for a total upgrade and make the move to energy-efficient and renewable technologies.
I'm keen to see how well it's working for those householders who've taken the plunge into the pilot programme. Sinead and Peter bought this house in Templeogue a year ago. The house was well presented, but having spent a winter there, it became apparent that there was serious work to be done.
It was freezing, I have to say. It was really cold.
And is that with central heating on and everything?
Yeah, well, when the central heating was on, it was okay, but as soon as you turned it off, the heat just escaped. And we kind of didn't know where, but it ended up being through everywhere, the floors, the windows, everywhere, so.
Right, and did you get a building energy rating carried out on the house? Yeah, what sort of level was
E
it?
for Eskimo.
E. And do you know how bad E is?
Yeah, E for Eskimo.
Yes, we've lived through it.
That's a good word for it.
Conditions are so bad in the house that it's beginning to become a health concern.
This was the freezing room,
Yeah.
you know? Bit of mould.
Absolutely. And there was mould on the
condensation.
walls, wasn't there?
Yeah. Condensation on the windows every night, every morning. Just generally damp. You know, like your bedclothes feel damp?
Sure.
Yeah.
Absolutely, of course. And I mean, there's so many houses, people living in rooms with these poor conditions, you know?
Yeah.
The small amount of visible mould may only be the tip of the iceberg. Mould can grow hidden behind plasterboard in cold and damp conditions.
Trying to keep the house at night time above the dew point temperature is critical to avoid the problems of condensation and the moulds forming, you know?
Yes,
and
yeah,
moulds
and-
then in a bedroom are very, very unhealthy.
Sinead and Peter have been accepted onto the Deep Retrofit pilot programme. They're taking on the challenge of bringing their home from an E to an A3 energy rating. Their aim is to achieve a comfortable and healthy home with very low energy running costs. The project looks at the whole house as a single system that requires specific technical expertise.
No, let's see, you've started the job here. What have you done so far?
We're starting with a full fabric upgrade, so we're looking at our windows, our walls, our floors, our roof. The main attic, we're putting our quilt insulation, but we also have a warm roof at the rear. And then introducing the renewable and energy efficient heat pump, low surface radiators, and also, you know, enhancing our air tightness. And when we enhance our air tightness, making sure there's a good mechanical ventilation system fitted.
You go, my darling?
Sinead, Peter and their 3 children have opted to continue to live in the house while the work is carried out. So the builders will work room by room, starting with the insulation of their suspended timber floors.
So we start in the front room. We've the hallway finished. Now we're in the sitting room. So you can see we took up the existing floorboards. We checked to make sure there's sufficient ventilation. There's no evidence of dry rot. The joists are in good condition. We're putting some latten underneath the joists just to support the insulation. Cutting in the insulation nice and tight, nice and snug. Fitting it in, foaming in any gaps, and then we're putting a Seagate airtight membrane right across the whole joists, turning it up on the side, and then sheeting it with an OSB board, and we can follow around afterwards and get the airtight seal on the perimeter.
There's lots of work to be done over the next 6 weeks to get this house to an A3 rating. In the meantime, I'm travelling to the north side of Dublin to visit another couple, Aisling and Cormac, who've also opted for the scheme.
Aisling and Cormac have just bought this house here in Donameath, and before they move in, they've decided to carry out a deep energy retrofit.
Hey, how's it going?
How's it going? Good to see you.
Nice to meet
Welcome.
you. How's it going? Obviously, we knew going into it that it needed an awful lot of work done to it, but I suppose we're looking for a house that we can live in forever. And I suppose the fact that now that we can get all these measures done means that the house will go from a G to an A3 rated house.
So it was a G.
Yeah, it was
Really,
the worst you
really
could get.
bad.
Yes.
It's impossible to heat a G-rated house, as you know. People live in one room in the winter because they can't afford to heat it. They just can't heat a G-rated house.
Work has already commenced, and the builders are under tight time constraints, as this project has to be complete in 8 weeks in order to qualify for this year's grants. And the works are extensive.
We are replacing all the windows and doors, applying external wall insulation, removing their existing heating system and installing a new heat pump with high efficient radiators. We're also installing 300 mil of attic insulation and solar PV panels. The total cost of the works that we're doing at this particular house is anywhere between 75 and 80,000, which is 50% funded by the Sustainable Energy Authority of Ireland. So, in fact, the client is paying approximately 40,000.
It's a large investment, particularly when you've just bought your first home.
We did have to apply for a loan from the bank, knowing that we will be increasing the value of the house, but it was something that was kind of essential you'd have to do to the house. So we had to take that cost, but essentially, at the end of the day, our energy bills would be lower.
But as the builders strip back the old house, it's evident that there's a lot to be done. I noticed there, the blockwork underneath the window there seems to be very, very thin. So really as poor a performance as you can get in a house, really. 9-inch hollow block with no insulation, 4 inches only here.
It's the way not to build a house.
The most shocking thing about this type of construction is that it's actually quite common. Many people live in these conditions, aware of the cold, but unaware of the health risks. The solution here is to apply external insulation to the walls, a thick polystyrene board, which will later be covered with an acrylic render. Externally insulating a house is usually much better than dry lining on the inside. And the reason for that is that by wrapping the house with insulation on the outside, you're minimizing cold bridges, you're keeping the whole structure warm and protecting the house at the same time. But also then the blockwork starts to act as a store of heat in the winter. There are some of the advantages on the outside. The side wall of the house can't be externally insulated due to the close proximity to the boundary with their neighbour. Yeah, so you've insulation now for dry lining here behind this wall because you couldn't go externally.
Exactly, yeah.
And I see you've taped it very well. I mean, the membrane is very good, the Intello, that's really good. You've taped it, all the joints, sealed it everywhere, and around the joists is very critical because driving vapour around there could create problems, interstitial condensation.
Exactly, and around the floor joist, it's imperative that the tape is done right. It's a tricky detail, but once it's done right, it's quite good. And then on top of the air tightness membrane, you can see now we're actually going to install a service cavity for all the electrical appliances to go down in that. So again, you're not puncturing the air tightness membrane.
Despite the enormity of the challenge, Aisling and Cormac are optimistic about the job at hand.
It's great to know that the investment we're putting in, it's the best you can put in now. Obviously, it might need to be updated over time, but for now, we just know that we're going to have a really warm house that's going to be as energy efficient as it possibly can be, because there is limits with an older house. It can only really come up to possibly around an A3, so it is ambitious, but they definitely think they're able to do it with sealing off all the different leaks that are happening of air and stuff like that in the house at the moment.
Back in Templeogue, the contractors are working at full tilt to stay on schedule. A major part of upgrading the fabric of the structure is replacing the old windows, but a delay in the window delivery could throw everything off course.
Yeah, it's certainly very open now, open to the elements. Hopefully the window delivery will be here soon to fill those gaps.
In the past couple of weeks, work has been completed on insulating the floors, the attic, the flat roof. And they've started the external wall insulation. A cavity in some of the walls also needs to be filled with further insulation.
The extension was built after the main house, so we have a cavity here. We're externally insulating all the house, but we've got a residual cavity about 40 mil that we're going to fully fill. Yeah. So that's expanded polystyrene, seals everything together before we apply the external insulation, which means that you minimise any thermal looping, you'll enhance the overall U value, and the finish outside is going to be consistent because we're wrapping everything.
Yes, because if you didn't do this, you fit the external insulation, and then hot air on the blockwork on the inside heats up, and then the hot air in the cavity would rise and go up to the roof.
It's a bit like having a duck-down duvet on your bed, and you're lifting it up 6 inches. So you've got this draft that's running underneath it. The best duvet in the world, but you've got air circulation. So we want to eliminate the air circulation.
And you're getting the benefit of the extra insulation.
Oh, absolutely.
So it's all good. As this house is going to be very airtight, it's very critical that there's a good ventilation system. Here, they have opted for demand control ventilation, which will mechanically extract moisture from kitchens and bathrooms and bring fresh air in as it is required. Meanwhile, outside, there's a very welcome delivery, and happily, they fit like a glove. Central to the deep retrofit is replacing the old gas heating system with a more ecologically sound air-to-water heat pump. The heat pump uses electricity but provides heat to the house at 3 to 4 times the efficiency of electric heaters. A heat pump is better to operate, leave it continuously on over the heating season, isn't it?
So the house is never going from hot, cold. The house stays at the one temperature throughout day and night.
In part 2, it's crunch time for our homeowners as their builders strive to meet their deadlines and pass the tests necessary for their grant approval. This week on EcoEye, we're following two couples who are striving to bring their homes up to an A energy rating. Both are making major investments to achieve this. But the good news is that an SEAI grant will fund 50% of the cost. In Donamead, things seem to be moving fast.
Are you on schedule?
Yeah, looking good so far. The weather has been on our side, and today we're progressing with the solar panel installation, the air tightness in the windows and doors, and the stove has recently been installed last week as well.
As part of the deep retrofit, Aisling and Cormac are installing solar panels. These will help power the heat pump, which in turn fuels the central heating. But the performance of solar panels depends greatly on how they're oriented and inclined relative to the sun.
So southwest was the best that we could get for the system.
Absolutely. And at that pitch now, and at mid-morning, with a blue sky, how much are these solar collectors generating?
Each pan will be bringing in roughly 150 watts of power. So we have 6 collectors altogether.
And what's their maximum that they could generate? What's their design?
A maximum peak of 260 watts per pan.
So say we put it at 45 degrees, Alan, is that okay?
I'm keen to see exactly how much better the panels perform if they're pointed directly at the sun in winter.
So it's bringing in roughly 300 watts.
Roughly 300 watts, it's giving more than it's designed.
It's giving more than it's designed, yeah.
Okay.
Just because of the orientation of it.
Right, so this is giving 300 watts, whereas they are at the moment giving 150.
Yeah.
So there's a big difference between the two,
difference,
isn't
yes,
there?
yes.
Yeah. So obviously the more you can orient to the south, the better.
The better the system will be, and more output of power you'll get.
Every detail of this building has to work to ensure that no cold drafts infiltrate the home and warm air is prevented from escaping through the structure.
Very often you go to sites and the external insulation is only carried up to the soffit, and that leaves a huge area of uninsulated wall, possibly about 300 millimetres.
Possibly in some situations, yeah.
Then you've got a massive cold bridge above that.
You could have 200, 300 mil of a cold bridge going right up into the soffit.
Yeah, and you could get mould and condensation forming there if it wasn't done.
Exactly, yeah.
Massive heat loss.
Exactly, yeah.
So you've extended it right up to meet the roof insulation.
That's it, yeah.
And how much attic insulation are you fitting?
300 mil in total.
And how much is on there already?
50 mil.
So another 300 on top of that, is it?
Exactly, yeah.
So 350, so about 14 inches.
Exactly, yeah.
So good, I'm glad you've done that.
Good.
Back in Templeogue, the moment of truth has arrived. It's time to test the air tightness of the house, a vital step in achieving the minimum A3 performance required to comply with the grant.
Most of the test is all preparation. First of all, we have to survey the house, do measurement survey. So it's based on the total surface area of the house. Then the next step is temporary sealing. So anything that is design ventilation has to be sealed up. So basically, that means any permanent vents, we have to tape them up. If there's an open fire, we have to seal them. They are factored into what's called design ventilation, so they are not taken into account in the tests.
This is important to you, isn't it?
Yes, definitely today.
Air tightness is critical for you.
It is. Today's the day of the big test. Hopefully it'll pass.
And I feel reasonably confident, you know.
Me too.
I think so.
Me too.
But I can't guarantee anything.
No.
And I know it's going to delay the whole thing if it does, of course, you know.
Yeah.
The contractor also has a lot riding on this test.
On a house like this, it's more difficult to get the enhanced air tightness where people are living in the house. There's certain areas that you cannot address like the way you would, you know, compared to like an empty house where you have a site. But yeah, we're very confident that we've enough done.
On the SEI grant, it has to essentially achieve a number of lower than 5. So if this achieves a number higher than 5, it will not get the grant. So it must get under 5.
So how do you think it's going inside?
Hopefully well. Yeah, fingers crossed for a good result.
Oh, I have some good news for you. It came in at 4.358, which is under a 5, which means it passed.
Brilliant. Brilliant.
Great news.
Well done.
Thank you.
Brilliant.
Back in Downamede, Aisling and Cormac have finally moved into their energy-efficient home, now rated A3.
The whole thing is integrated now.
Exactly, to kind of maximise and to make sure we get the A3 rating, everything had to be energy efficient, so all the light bulbs in here are LEDs.
And then the solar?
The solar panels on the roof, they power the demand control ventilation and then also power the heat pump as well.
And are these all working well?
The ventilation works on its own, there's no controls, and the heat pump just ticks away. The heat pump was always like the main point, but what we didn't know was the ventilation system. That is brilliant. I'd recommend that to everybody. It really does everything in the bathrooms, the kitchen utility. There's clean air throughout the house.
So besides the grant, how much did you both have to spend here?
So we figured that the energy works to the house came to around 80,000. Half of that then was grant funded, and then we spent another extra 20 on changing the rooms around. So I'd say all in all we spent maybe about 60,000 on the house and the works to be done to it.
So really the big question here for both of you is, has it been worth it to go to the effort you've made?
We know that the house is actually the highest level, the highest standard, and it definitely was going to get an A rating. So we felt that the investment was worth it because we would have had to spend that money anyway.
Sinead and Peter are also finally able to experience the huge difference between an A3 and an E-rated house.
We used to joke sometimes it was warmer outside than it was inside, so we are just thrilled with the difference.
Yeah, since we've had the work done, the house is just a constant temperature. The weather's got a little colder over the last few weeks, so we really noticed the consistency of the temperature. Every corner of the house is the same temperature.
The air quality in the home, you find that's good?
The whole house feels much healthier because it's the fresh air all the time, and again, no condensation, no damp, so it's fabulous.
The Deep Retrofit scheme is one that will demand huge investment from the state if it is to be rolled out beyond 2019. The SEAI believe it is well worth the cost.
The energy we use in our homes accounts for about 25% of the energy used in the country as a whole. A part of our role at SEAI is to lead Ireland towards a low-carbon future. So to do that, we need to use less energy, we need to use cleaner energy.
This pilot programme is open to homes with a BER of C or less. Works can only be carried out by SEAI-approved contractors once the house has been deemed suitable for the scheme.
Because the funding was about 50% of the cost of the works, it obviously took a bit of time. It's not something that you immediately apply for like a bank loan and then the money's in your account 2 weeks later. There is a process, there is a lot of stages that need to be done. It's not a quick fix, but in the long term, it's definitely an investment and it's definitely worth it.
Yeah.
Now, you decided you're going to do the fundamentals first, and that's what I really liked about this project, you know? How do you feel about that now? In other words, that you've done this, but you've still got kitchens, bathrooms, other things possibly to do.
I think Duncan, you have to get the basics right. You could end up doing those other things and then realising the house is not warm enough and maybe having to undo some of those things. And maybe then it would be more of a partial job than a full job. So we're really happy to have done this stuff first, and then to do the other sort of more decor style things afterwards. You know, the outcome that we've achieved has been amazing. We now have a warm A3 rated house.
I don't think you can bury your head in the sand and put nice carpet down and a nice, wallpaper or whatever on the wall. You really have to think about, the future, and if you're going to live in the house, make sure it's, the best house you can make it.